This video is for the domain and range in various forms notes, and all we're looking at today is just linear functions. Okay, so we're going to start with continuous. So there's a difference between continuous and discrete. Continuous functions, when graphed, they look like this. All the points are connected. Discrete is when we pull data off of a mapping like this or even off of a table, and we're not sure if the data is connected or not. That's a discrete function. Okay. So a continuous function is a function whose values are continuous or unbroken over the specified domain. So here we've got this function f of x equals negative 1/3 x plus 2. We've got it graphed as well. And we're going to write the domain verbally in interval notation, in inequality notation, and in set notation. So verbally, the domain, my x's. This graph is going to go on and on forever. That's what the arrows mean. So my domain, all real numbers, I can plug any value of x into this function. And the range is also going to be all real numbers, because it's going to continue to go up through all the y's and down through all the negative values of y. So in interval notation, my domain would be from negative infinity to positive infinity, all numbers. The range would be the same, negative infinity to positive infinity. In inequality notation, we would just write that x is a member of this set of rational numbers. Y would also be a member of this set of real numbers, apologize. And then in set notation, we would say x is the set of real numbers, and y, the domain, would be as a member of this set of all real numbers. All right, another type of continuous function we may see is something like this, where we do have endpoints. So in this case, verbally, our domain, we look at the x's. So I'm starting here at negative 6. I'm ending here at positive 2. So x is going to be all real numbers greater than or equal to negative 6 and less than 2. Now, how I know that this is greater than or equal to, it's a solid dot. So less than or equal to, greater than or equal to is a solid dot. Less than or greater than is an open circle. So the range, I'm going to look at my y's. So my smallest y is a negative 5. My greatest y is a positive 25. So my range would be y is all real numbers greater than negative 5. So again, greater than, because it's an open circle down here at negative 5. And less than or equal to 25. All right, in interval notation, so my smallest x is a negative 6. It's a solid dot, so that would be a bracket. My largest x is a 2. It's an open circle, so that would be a parentheses. For the range, my smallest y is a negative 5. It's that open circle, so it's going to be a parenthesis. My largest y up here is a 25. It's a closed circle, so it would be a bracket. And then we could also add x is in the set of all real numbers, y is in the set of all real numbers. Inequality notation, -6 and 2, so we could just write -6 is less than or equal to x, which is less than 2. For this one, we're starting at -5. Parentheses, open circle, so just a less than sign. Make sure you change it to a y though, because we are talking about the range. And it's less than or equal to 25. And then in set notation, -6 x 2. Ooh, not much space to write there. Just do your best to get it to fit. And then for the range, so just several different ways that we can write domain and range. Okay, so looking at now discrete functions. So a discrete function is a function whose values are distinct and separate. They're not connected values and they're not continuous. So both of these, this mapping and this graph, represent the same thing. So our domain. On a mapping, typically your domain, your x is on the left and your y or your input is on, or output is on the right. Again, we could look at the graph and pull the x values off of that. But how I'm going to write this domain? I'm going to start with the smallest value of x, which is a -6, and work up from there. So I'm going to write them in numerical order. Same for the range. I'm going to start at the smallest value and write them in numerical order. And so this is a type of set notation that we can use for these discrete functions. All right, so with a table, we do it the same way. Domain is our x, range is our y. These numbers are already in numerical order, which helps. And then range would be the y values. Here, I'm actually going to start at the end here, -38, -28, -18, -8, 2. I have seen it done both ways. I've seen it flipped where the domain it matches up with its range. I'm not going to be too picky about it. Now on a graph, if we're given just the graph, we have to pick out our x and y values. So remember, x values are on the horizontal axis, y values are on the vertical axis. So my x values here, I've got a -5. This one is at a -1. Here's a 2. Here's a 6. So that's my domain. For range, I'm going to start at the smallest y value, which is down here at -4. And I've got this one here at -2. This one here is at 3. And then this one up here is at 5.